actually hope we do go to a second round of questions. Dr. Dickerson, my question is for you. A key to some recent findings is the discovery of a chemical signature that differentiates emissions from oil and gas activity from those given off by automobiles, cow manure, or other sources of volatile organic compounds. The finding was fundamental to the conclusion that oil and gas activity contributed about 55% of the volatile organic compounds linked to unhealthy ground-level ozone. Can you please tell me whether this chemical signature will help determine how much ozone levels are due to things like gas wells versus the impact in a metropolitan region such as ours, where we experience high levels of ozone, bad air quality, and we're always at the top of those lists? Can you tell me how you think that chemical signature could help in making determinations for EPA and using its flexibility in setting ozone standards?
Yes, happy to. I have to say, wow, I didn't expect such technical questions. This is absolutely true that oil and gas operations have a characteristic signature of isomers of pentane and other hydrocarbons that allow you to differentiate those from tailpipe emissions. And these are indeed useful investigations. Ozone can be made in a power plant plume that has one chemical signature. It can come from tailpipe emissions that has a different. Forest fires are not as efficient as internal combustion engines, but they can make ozone as well. They have yet another chemical signature. And all of these are indeed distinguishable by hydrocarbon ratios as well as other trace gases and aerosols.
So let me just ask this, and maybe this goes to Mr. Vandenberg. Wouldn't it be the case that if we're able to make those distinctions in the source by this chemical signature, that could enable us to make adjustments in a way that would accommodate some of the interests of some states that are claiming, or regions that are claiming to produce ozone that they don't have any, where there's ozone present, they don't have any control of, and we might actually use the EPA could use its regulatory authority to make some distinctions in those regions, so we really do get at the heart of the problem?
Thank you for the question. And again, to reinforce the comment, I think with the advancements in science in terms of looking at chemical signatures, that's the kind of information that I think helps inform the decision-making downstream in terms of what is a natural event, what is the source of the contributors to the ozone that's in the air. And I think that's a very important type of information that can be brought to bear.
And Mr. Oltmans, I probably should direct this really to you, because it's the work of the scientists at the Cooperative Institute for Research in Environmental Sciences at the University of Colorado that you're representing that actually helped to reach this conclusion. How do you think the discovery can clarify some of the questions that we have about background ozone levels and contribute to EPA's research and review process?
Yes, I'm familiar with work that you're discussing. Most of it took place in the Front Range of Colorado, Utah, and in Wyoming. Personally, I'm not sure that this is that important a factor in determining the role of background ozone. One of the things I think that's misinterpreted about background ozone, it isn't that often that background ozone itself leads to a violation of the standard, but it gives very little room for regulatory control to bring ozone levels down to the standard. In other words, it's very unusual for ozone to be 60 parts per billion in what would be considered background conditions. But as you push up close to 60 parts per billion on the background, it is very difficult to find any regulatory scheme that will reduce the result from photochemically produced ozone either over a region or locally to be controlled and meet the standard. I think that's one of the things that needs to be considered, and background ozone itself is not the violation of the standard by the background, but how difficult it makes it to control.
I think I understand that. I guess my point, and we can get to this at some other point, I suppose, is that knowing, for example, that 40% is coming from that background ozone that we don't have any control of, would that allow then the EPA to exercise somewhat more flexibility in those areas in order to have ozone settings that actually reflected the things that we could have control over? Anyway, with that, I think my time has expired. Hope we get to a second round.